Hello everybody. Today we will discuss problem B1 from US Physics Olympiad 2009 USAPHO. That was a semi-final problem on the second day. On the second day there were two problems, B, and there were 90 minutes for two problems. But before that, please subscribe for this channel. In that case, you will get everyday good problems. Thank you. Problem. A bowling ball and a golf ball are dropped together onto a flat surface from height h. The bowling ball is much more massive than the golf ball, and both have a radius much less than h. The bowling ball collides with the surface and immediately thereafter with the golf ball. The balls are dropped so that all motion is vertical before the second collision, and the golf ball hits the bowling ball at an angle alpha from its uppermost point, as shown in a diagram. All collisions are perfectly elastic, and there is no surface friction between the bowling ball and the golf ball. After the collision, the golf ball travels in the absence of air resistance and lands a distance L away. The height h is fixed, but alpha may be varied. Question: what is the maximum possible value for L, and at what angle alpha it is achieved? You may present your results as decimals, but remember that you are not allowed to use graphical or algebraic functions of your calculator. Solution. First, let's count what is the speed of bowling ball and baseball. Right golf ball collide with the floor, and right before it collide with the baseball. That will be V equal square root from 2gh, and before collision of this baseball with the bowling ball, baseball is going down and bowling ball is going up. And because this bowling ball is very heavy compared to baseball, we can think that this is like a wall to baseball. And the best way to do is to go to frame of reference of this bowling ball, which is going with the speed v upward. So in this frame we have speed of baseball equal to this one, negative 2v. And with this speed it's collide with bowling ball, which can be accepted as a wall which has a normal on the angle alpha to vertical. So it means that baseball will collide with it and will rebound on the angle 2 alpha from vertical. And we can write equations for its velocity. So in this frame of reference, Vx prime for baseball will be V prime multiplied by sine alpha, and Vy prime equal V prime cosine alpha. And now we can return to our original frame of reference. In this original frame, Vx will be the same, but the Vy, we need to add V to return to our original frame. So finally we have these velocities in x and y direction. And this is all what we need to solve this problem. Let's do this. First, let's theta will be 2 alpha. In that case, we can count what is the time of travel. That will be this expression 2vy over g, and after that we can find what is total distance L. That will be this one. So it means that now we have to find what is maximum for this function. So we need to take a first derivative by theta from this function and equalize it to 0. That will be a quadratic equation to cosine theta. We can solve this, and the solution is this one. Of course, only a positive sign is acceptable. Negative sign, it means that alpha is going down, and it's not good. This is not our case. And approximately cosine theta equals this expression, 0.593. Sine approximately equals 0.805. And finally we can count what is a distance for that angle. That will be around 14.08 h. And if we have this sine theta equal this one, it means that theta equal 53.6 degrees, and alpha is just half of this, which is 26.8 degrees. So that's the solution. This is distance, this is angle.